Okay, students, in this video we are looking at the properties of logarithm. And the first property of logarithm is called the property quality for logarithmic equations. And basically what this says is this: if we have the log base b of x, and that's equal to log base b of y, as long as the two bases are the same and both expressions are equal, we can say x is equal to y. Okay, so an example of this could be logarithm base 3 of x is equal to logarithm base 3 of 7. If that's the case, we can say x is equal to 7. Okay, so let's work out a couple examples that will help us with today's lesson. Logarithm or log base 4 of x is equal to 5 over 2. Remember that the basic definition of logarithm states that whatever the base is, 4 to the 5 over 2 is equal to x. Okay, so in this case, you can just put this in the calculator and work it out if you want. 4 to the 5 over 2, or you can try to change this base to perhaps 2 squared to the 5 over 2. So 2 squared. So remember that when we have an exponent raised to another exponent, we can multiply those two. So I'll get 10 over 2 is equal to x. And 10 over 2 is 5, so 2 to the 5th equals x. Well, we know that 2 to the 5th is equal to 32. So x is equal to 32. Okay, I hope that makes sense. Let's do a couple more problems like this, just to get started. There are more properties of inequalities, and we will get to all of them here in a couple of minutes. All right, so another example is log base 5 of 2x squared minus 6 is equal to log base 5 of 4x. All right, so this is another example. Once again, you guys notice that the bases are both the same. So log base 5, log base 5, and both of these expressions are equal. So we can focus on these two parts. 2x squared minus 6 is equal to 4x. Okay, so I would try to get everything on one side, just because I really can't combine. I can't combine like terms, so I would move the 4x to the left side. Remember, it's you need to use the inverse, so I would get 2x squared minus 4x. You're moving the 4x to the left. Minus 6 is equal to 0. All right, now, can we divide all these numbers by a common factor? And the answer is yes. I can divide everything by 2, even the 0 on this side. If I divide everything by 2, I get x squared minus 2x minus 3 equals 0. Now from here, we can go straight into the factors. What are two numbers we can multiply to get x squared? Well, x times x. What are two numbers we can multiply to get negative 3 and get a sum of negative 2? Well, that's going to be negative 3 times positive 1. All right, so bring that over. You got your two factors, x minus 3 equals 0. Remember that? X plus 1 is equal to 0, and then solve for x. So in this case here, if I add 3 to both sides, I get x equals 3, and x is equal to negative 1. Okay, now there's two answers, 3 and negative 1. However, we can never have a logarithm of a number. So if I take this one here, for example, plug it in for x up here, I will have log base 5 of 4 times negative 1, and so that's equal to log base 5 of negative 1. This doesn't work. We can never have a logarithm of a negative number. So even though this was a solution down here, this is what we call an extraneous solution, which means even though it was a solution, it does not make sense. So in this case, this is only the answer, x equals to 3. Okay, I hope that makes sense. Now let's look at more properties of logarithms. There's a couple more properties we have to look at. So let's clear this really quick. Let's clear this. All right, so there's 3 more properties, and the second one, it's called the product property. The product. Let me change the color. The product property of logarithms. All right, so basically what this says is this: if I have the logarithm base b of m times n, that's equal to, so this is product because you're multiplying those two, this is equal to logarithm base b of m plus logarithm base b of n. All right, so an example of this, could be logarithm base 5 of 8 times 4. So we're multiplying these two numbers here. So this is equal to logarithm base 5 of 8 plus logarithm base 5 of 4. Okay? We call that the product property of logarithms. Let's cut this down. Okay. The next property is what we call the quotient property. The quotient property of logarithms. Here we go. Let's change the color. Quotient. So you guys remember what quotient means? Quotient is the answer to your division problem. So the quotient property of logarithms. So if I have log base b of m divided by n, that will be equal to log base b of m minus logarithm base b of n. So the difference here is that you're subtracting them when you have a quotient. So an example of this could be, let's say I have the logarithm of 8 of 2/3. That's going to be equal to logarithm 8 of 2 minus logarithm base 8 of 3. All right, it's called the quotient property. There's one more. There's one more, so I need to make some room for these over here. So let's clear all this. And this one is called the power property. So the power property of logarithms. So this one states that if I have the logarithm of base b of m to the n, okay, power because we have an exponent, this is the same thing as if I write it as n times logarithm base b of m. So essentially we're just moving the n to the front and we multiply that times all this right here. One example could be the logarithm base 2 of 3 to the 7th. So this is equal to 7 times logarithm base 2 of 3. All right, so those are the properties. Now let's look at some examples, more examples where we can utilize these properties. So there's 3 properties that we looked at: product property, quotient property, and the power property. All right, so let's come up with a couple examples where we can get to apply all of these. All right, so the first one is, it says, so let's say we're going to use log base 3 of 5. So we know that this is a given. It's equal to 1.465. Okay, so this is already given. We are going to approximate the logarithm base 3 of 405. All right, so we need to use this fact here to approximate this. Well, that means that the number 5 basically divides 4 or 5. So the question is, how many times can 5 divide 4 or 5? And the answer is, well, it's about 200, it's about 81. It's about 81. Okay, so this is what I have right now. Think about the 3 properties that we looked at: product property, quotient property, power property. Which of those 3 can I utilize? And the answer is the product property. Why? Because those 2 are being multiplied. So I can rewrite this as logarithm base 3 of 5 plus logarithm base 3 of 81. And we know that the logarithm base 3 of 5 is already given to us. That's 1.465 plus, this is where we need to get comfortable with basic multiplications. So we talked about this in the last section. 3 to the what is 81. Remember, you guys solved this already. 3 to the what is 81. Well, I know that 3 to the something is 81. What's that something? What's that something? Well, it's going to be 4. So all this right here becomes 4. So when I add these two, I get 5.465. And that's the answer, 5.465. Okay, if you have to pause this, go ahead and pause it. Review it. Let's look at a couple more problems. Maybe two more. Let's it's another example. Let's use logarithm base 3 of 5 is equal to, let's do the same thing as before. It's 1.465, and we are going to approximate the answer of, or the value of logarithm base 3 of 9 divided by 5. 9 divided by 5. Okay, let's go back to the three properties of logarithms. So we have product, quotient, and power rule, or the power property. Which of those can I utilize here? Well, this is division, so I need to use the quotient property. All right, quotient property. All right, so that's going to be logarithm 3 of 9 plus, not plus, this time is, it's a quotient, so it's minus logarithm base 3 of 5. Okay, so we already know what log base 3 of 5 is. It's 1.465. All right. Now, basic definition of a logarithm. 3 to the what is 9? 3 to the what is 9? What's that number here? Well, that number has to be 2. 2. So 2 minus 1.645 is equal to 0.535. That's the approximation. That's the answer right there. Okay, let's do one more, and we'll be done with this entire lesson. Let's do all right, let's use a different value this time. Let's use logarithm or log base 2 of 6 is equal to 2.585 to approximate the value of log base 2 of 1,296. So when it's written as use this value, that means you need to use that value in here. So let's see, we know that 6 will divide this number. How many times? Okay, how many times can 6 go into 1,296? You can divide that, and what I get is I know that 6 goes into that number. It's a perfect number. It goes, it's going to be 6 to the 4th, because 6 to the 4th is 1,296. So if I look at this, I'm going to utilize the power property. And remember what that states. It says that the number and the exponent can be moved to the front to multiply this entire log. So 4 times logarithm base 2 of 6. And I already know that log base 2 of 6 is equal to 2.585 times 4. If you multiply that times 4, you get about 10 point, let's see if I get this right in my head, 10.34, give or take. All right, check that. If it's wrong, I will give you a bonus point. All right, so this is these are the properties of logarithms. Please let me know if you have any questions. All right, you guys take care.